Problem similar to civil engineering board exam. A parabola has an equation of y squared is equal to 8x. Find the equation of the diameter of the parabola, which bisect chords parallel to the line x minus y is equal to 4. The first thing you need to do is to find the slope of these parallel chords. Okay? These parallel chords are also parallel to this given line. Therefore, whatever is the slope of this given line, that will be the slope of these parallel chords. Alright? So the equation of this line, if we are going to rearrange that, is y is equal to x minus 4. This is in the form y is equal to mx plus b. Therefore, the slope is equal to 1. Okay? Then, we are going to find the slope of this parabola. Lagyan ng sabon, parabola. Differentiate this one. This will become 2y, y prime is equal to 8. Now, we are going to plug in this value, the slope of the parallel chords, to the slope of the parabola. This will become 2y times 1 is equal to 8. We have this equation y is equal to 4. And this is our answer. This is the equation of the diameter. What happened here? If you are the one who is only interested on solving this problem, you are dismissed. But if you want to understand why this is happening, stay with the video. Good day, Mathalino. Again, I am Junvert. We are required to find a weird quantity, which is the diameter of the parabola. It's look like, is there a diameter of the parabola? What is that? Anyway, this is a board exam problem, so this is a legit question. What really is the diameter of a parabola? Let us see that in a graph. Alright? We have this parabola that is open to the right. Y squared is equal to 8x. Why it is open to the right, that is worth another video. So I will not discuss here why this is open to the right. But for a little background, we cannot assign x a negative value here because if the x is negative, y will become an imaginary number. Okay? We have this given line with the slope equal to 1, meaning this is a 45-degree line, and with y-intercept equal to negative 4. So the point here is 0, negative 4. That is the y-intercept. And we are required to find the diameter of the parabola which bisect chords parallel to this line. So we have this infinite number of chords parallel to this line. Another chord that is parallel to this line, another chord, and so on. Okay? These are the midpoints of these chords. Because our drawing is accurate, we see it directly that if we are going to connect these lines, we can create a straight line. And that is the diameter of the parabola. Okay? Why is our solution like this one? What's the reason? Just continue watching. I will show you here that this equation will work to any type of conic section. It can be ellipse, it can be parabola, hyperbola. Of course, it can be a circle. Okay? There's no problem with the circle. It's very easy to find. Let us say that we have this ellipse, x squared all over 9 plus y squared all over 4 is equal to 1. And we are required to find the diameter of this ellipse that will bisect all chords with a slope of negative 2/3. Okay? What is our procedure in our previous solution? Our procedure is this one. We are going to differentiate this equation. Okay? So what is the derivative of this equation? We have this 2x all over 9 plus the derivative of this one is 2y y prime all over 4. The derivative of 1 is 0. So we have this equal to 0. 2 over 9 of x plus 2 over 4 is actually 1/2. So we have y over 2. And we are going to plug in this negative 2/3, the slope of the parallel chords, to the slope of this ellipse, the y prime. Okay? When we do that, the result is the equation of the diameter. All we need to do is to simplify this equation. Okay? So we have this 2 over 9 of x, transpose this one, we can cancel this 2. So we have this negative, transpose that will become positive 1/3 of y. Okay, cross multiply this y. This will become 3 over 9 is 1/3 times 2. So we have the value of y is equal to 2/3 of x. And this is our equation of the diameter. No need to draw. But for the sake of discussion, let us check this solution using the geometry. Okay? We have this ellipse. Our ellipse has a major axis. What is the length of the major axis of our ellipse? Center at the origin. So this is 0, 0. This is our x and this is our y axis. Okay? So this ellipse is in the form x squared all over 3 squared plus y squared all over 2 squared is equal to 1. Therefore, the semi-major axis, the half of the major axis is 3. This is a total of 6 units, the major axis. And half or the semi-minor axis is 4, is 2. The whole minor axis is equal to 4. So the value here is 2. Alright. What is this point? If this is the origin, meaning this point is 3, 0. How about this point? This is the origin, so therefore, the coordinates of this point is 0, 2. Okay? Then we can connect these two vertices, a major vertex and a minor vertex. We can connect that. This line has a slope of negative 2/3, meaning this is one of the chords that defined here. Okay? Rise is negative 2, that is downward. Run is positive 3, to the right. The slope of this line is negative 2/3. This is actually intentional so that we can illustrate this problem using geometry. Okay? Now, there are other chords parallel to this line. Infinite number of chords parallel to this line. With the slope also negative 2/3, of course. And we are going to bisect or divide these chords into 2 equal segments. What is the equation of that dividing graph? Or in this case, that is a straight line. What is the equation of that dividing line? This point is the midpoint of this line. Because we are given the endpoints, we can find the coordinates of this line. Can you remember the midpoint formula? x1 plus x2 divided by 2. So we have this 0 plus 3 divided by 2 is 1.5. y1 plus y2 divided by 2, that will become 2 plus 0 divided by 2 is 1. That is the coordinates of this point. And another midpoint of all the chords that we have. And we are going to connect that with this graph. Okay? It happened that this is a straight line. Alright? What is the equation of this line? If we are going to find the equation of this line, we can use the slope-intercept form of a line. Y is equal to mx plus b. Can you remember that? We have this slope, we have this y-intercept. What is the slope of this line? The yellow line. The slope actually is rise over run, and we can get that from this triangle. Right triangle. We have this slope, rise over run, which is 1. That is upward, positive. And run to the right, positive also. So we have this 1.5. Rise over run. Alright, this is an upward line, so we have this positive slope. Then times x plus the y-intercept. What is the y-intercept? Of course, this line passes through the origin. The value of y here is 0. The y-intercept is 0. Okay? 1 divided by 1.5 actually is 2/3. So this is our answer. Sir, I like the second solution than the previous one, calculus. The geometry here is beautiful because we have this negative 2/3 slope. What if our slope is not negative 2/3? What will happen to our endpoints? We cannot define an endpoints that are elegant to solve. This geometry solution happened to be elegant because we have this chord that will pass through these 2 points which are in a whole number. Okay? If we happen that we have this type of chord, it's not this solution is not favorable anymore. Okay? I highly recommend this approach. No need to draw. Alright? Are you now convinced that this solution will work because of this presentation? Because I am not going to prove here why this will work using the calculus level. It's worth another video, so I will not do it here. I just presented this to you, but this is not a concrete proof that this solution is correct. But I think this is enough to convince you that what we did here is correct. Okay? Now, I think you observed already that there are other chords that parallel to this diameter, required diameter. Of course, there are chords that are parallel to this given diameter or required diameter. These chords. And if you are going to bisect these chords, okay, divide this into two equal segments, we can also create another diameter. Okay? This diameter is actually a conjugate of this diameter. And vice versa. They are conjugate to each other. So what are conjugate diameters? A conjugate diameter is a bisector line of the chords parallel to the other diameter. And vice versa. Now let us go back to our parabola. Say we have this parabola, which is open to the right. Say this is our x and y axis. I will change color for the parabola itself. And this one. Parabola open to the right. Let us say the equation of this parabola is y squared is equal to 4ax. This is the standard equation of the parabola, vertex at the origin open to the right. And we know that 4a is the length of the latus rectum of the parabola. And we have these chords, parallel chords. Okay? One of the parallel chords. Let us say that the equation of this line is y is equal to mx plus b. Okay? Then, there are infinite number of parallel chords that we are going to bisect. And these are the midpoints of these chords. Okay? Assuming that we don't know that this will create a straight line, so we just connect these points with a smooth curve. So this is our smooth curve, and we are going to find the equation of this graph. The diameter of it is defined as the diameter of the parabola. All right. Let us find the intersection point of this parabola and this line, one of the parallel chords. Okay. Let us call this point 2, and let us call this point 1. Okay? The coordinates of this point 1, let us call that x1, y1. And the coordinates of this point, let us call that x2, y2. And we know that this point is the midpoint of this line segment from point 1 to point 2. Let us call the coordinates of this one xm, ym. M stands for midpoint. xm, ym. Okay? And we know that xm is the average of x1 and x2, and ym is the average of y1 and y2 from our geometry. Okay? Now, if we can find this intersection point, we can define the xm and ym, which belongs to this graph, the diameter of our parabola. And if we have this equation that relates to xm, ym, we can determine this graph, the equation of this graph. Alright? So, to solve for these intersection points, this point and this point, let us solve this equation and this equation simultaneously. Let us simply equate the y squared of the line equal to the y squared of the parabola. Okay? What is the y squared of the line? That is mx plus b raised to 2 is equal to the y squared of the parabola, just copy that one, 4ax. We can expand this one. M squared x squared plus what? We have 2 times mx times b, that will become 2mb times x plus b squared is equal to 4a squared. Now, not 4a squared, 4ax. Now, we can combine these two because they have this value x. Okay? We have this m squared, x squared plus 2mb minus 4a, factor the x, plus b squared. What is this equation? This is actually quadratic in x. We have this x squared and we have this x. Okay? Quadratic equation in x. Our purpose actually here for solving these 2 points is to determine the xm, not the individual value of x1 and x2. Alright? So, let us find a simple way to solve the xm without solving directly the x1 and x2. How to do that? Do you remember your one concept in algebra for quadratic equation? Sum of roots. We can use sum of roots. Okay? This quadratic equation has 2 roots, x1 plus x2. What is the formula for that? Negative b over a. Okay? What is our b? That is the coefficient of x, the coefficient of x. So this is the b. Negative of that one, 2mb minus 4a all over a. What is the value of a? This a is the coefficient of x squared. That is m squared. Take note, our quadratic equation is in the form ax squared plus bx plus c is equal to 0. The sum of roots x1 and x2 is negative b over a. And it happened that our our b is this one, the coefficient of x, and our a is this one, the coefficient of x squared. So this is the sum of roots, and what we need is the xm. From the midpoint formula, xm is actually equal to x1 plus x2 divided by 2, average of this x1 and x2. What is x1 plus x2 divided by 2? Divide 2, this will become positive. Okay? I will write it here. This will become 4a. Okay? 4a minus 2mb all over m squared. That is the value of x1 plus x2. And the average of that is what? I will go back to green. The average of that will become divide 2. 2a minus mb all over m squared. That is the xm. Now, we are going to substitute this xm to this equation, because take note that this point belongs to this line, meaning we can substitute xm to this equation. With that move, we can get the value of y, and that y is called actually ym. Okay, what is the value of ym? Ym is equal to mxm. Okay? xm plus b. If we are going to substitute xm in here, what we get here is the ym, because we are talking about this point. Alright? So substitute the value of xm. We have this m times 2a minus mb all over m squared plus b. What will happen to m? Cancel out. We can cancel out this m, 1m here. So we have this, go back to green. We have this value of ym is equal to 2a minus mb all over, but I am going to combine this fraction to this quantity. M times b is mb plus mb all over m. Okay? Cancel out mb. This will sum up to 0. Negative mb, positive mb. What remains is the value of ym. We have this value of ym equal to 2a all over m. Okay? What this equation said to us? This is actually the equation of the diameter. Because whatever is the y in this chord, that is equal to this one. The value of y at the midpoint of this chord is equal to this one. The value of y at the midpoint of this chord is equal to this one. free from x. Okay? And this is a constant value. That's why we have this horizontal line parallel to the x-axis. Why we said this is a constant value? Because the slope of the parallel chords are the same. The slope of this line is equal to the slope of this line is equal to the slope of this line. All these chords are with slope m. Okay? And for our parabola, the length of this a is also constant. For a particular parabola, this value will not change. Alright? So if we go back to our problem is y squared is equal to 8x. Meaning our 4a here is 8. Our 4a, the length of the latus rectum is 8. So half of that, which is equal to 2a. This is equal to 4. Our equation there for the line is y is equal to x minus 4. That is the equation of the line, given. This is the given also. Okay? Therefore, our m there is 1. M is equal to 1. That's why if we are going to use this equation, what the result will be, y is equal to 4 all over 1, which is our answer. Y is equal to 4. Okay? This is the equation of our diameter. Okay, that's it for the CE board problem. I hope you learned something for this video. If you have more questions about this topic, just comment below. Thank you for watching. Have a good day. See you in our next video. Bye-bye!